In this video, we're going to have a look at the different type of equations that we'd expect S1 pupils to be able to solve at the end of the S1 equations topic. I've kind of branched these into 6 different major ideas, and this might be either 1 or 2 videos. Okay, so the first thing we'd have a look at would be examples like this here. X plus 3 equals 14. The idea of solving equations is we want to undo things. The opposite of addition is subtraction. The opposite of subtraction is addition. The opposite of multiplication is division. Division, multiplication. Our objective when we solve an equation is we want to get the letter on its own on one side of the equal sign. At the minute, we've got x plus 3. So we want to get rid of that plus 3. So we ask, what's the opposite of plus 3? Minus 3. We subtract 3 from both sides. What we do to one side, we must do to the other. When we subtract 3 from the left, we're going to be left with x, because 3 take away 3 is 0. So we're just going to be left with x, and that's going to be x equals 11. Because, if we think about this, 11 plus 3 makes 14. This one here, x minus 6 equals 8. Our objective is to get x on its own on one side of the equal sign. So we've got x subtract 6. We want to do the opposite of subtract 6. We're going to add 6 to both sides. Add 6, add 6. That's going to leave x on the left-hand side on its own, x equals 14. Why does that work? Well, because 14 minus 6 is 8. Last example in this style, 4 equals x minus 3. This looks a little bit different because the x is on the other side of the equal sign, and that's totally normal, that's okay. Our objective is we want to get x on its own. So we want to get rid of this minus 3. How do we get rid of minus 3? We add it. So we're going to add 3 to both sides. 4 plus 3 is 7, and that's equal to x. And if 7 equals x, we can then say, well, x equals 7. Okay, and that would be our answer there. Why does that work? Well, if this is 7, 7 take away 3 is 4. That's the first style, when we're undoing adding and subtracting. We then had a look at examples such as this here. 2x equals 18. Our objective is to get x on its own. So we now look at what the 2 is doing here. The 2 is not adding to the x, it's actually multiplying the x. So we do the opposite of multiplication. The opposite of multiplying is dividing. We'll divide both sides by 2. That's going to give us x equals 18 divided by 2 is 9. X equals 9 is our answer here. Why? Well, 2 times 9 is 18. 20 equals 4x. The objective is we want x on its own on one of the sides of the equal sign. So we have a look here, and it's attached to this 4x. That means 4 times x. The opposite of multiplying by 4 is dividing by 4. 20 divided by 4 is 5. We're going to have 5 is equal to x. And then that leads to x equals 5. Why does that work? Well, 4 times 5 is 20. Okay, so when we undo multiplication, we divide. If we have a look at these two examples, we've got x over 8. X over 8, let's write this down here. X over 8 means, it's a shorthand. It means x over 2, apologies. X over 2 literally means x divided by 2. So if we have a look here, we want to get the x on its own. At the minute, it's being divided by 2. The opposite of dividing by 2 is timesing by 2. When we times both sides by 2, these two technically simplify here, and I'm going to be left with x equals 16. The answer here is 16. Why does that work? Well, 16 divided by 2 is 8. 5 equals y over 4. We want y on its own. At the minute, it's over 4. That means it's being divided by 4. The opposite of dividing by 4 is to times by 4. I'll times both sides by 4. That's going to lead to 20 is equal to y, which we can say that y equals 20. Why does that work? Well, 20 divided by 4 is 5. Okay, we can take this a wee bit further now. And we'll look at examples such as these, where we've got multiple steps here. Let's have a look at the first one. This is probably the last examples in this first video. The objective is we want to get x on its own. I've got 2x plus 1 equals 17. So we've got a multiplication and an addition. what we want to do is we want to undo the addition first. The opposite of adding 1 is subtracting 1. So we're going to have 2x equals 16. 2x means 2 times x. The opposite of times by 2. Dividing by 2. And that's going to lead to x equals 8. Why does that work? Well, 2 times 8 is 16, plus 1 is 17. 23 equals 5x minus 2. Where are we? There we are. We want to get the x on its own. In a minute, we've got 5x minus 2. So we've got a timesing and a subtraction. We want to undo the subtraction first. So the opposite of taking away 2 is adding 2. That's going to be 25 equals 5x. That is multiplying x, that 5, so we're going to divide by 5. 25 divided by 5 is 5. So that's 5 equals x. And that leads to x equals 5. Why does that work? Well, 5 times 5 times 5 is 25, take away 2, which is 23. 6x minus 10 equals 8. Objective, we want to get the x on its own. Anymore, I can't. Right, there we go. Apologies, give me a wee second. We want to get the x on its own on the equals, on one side of the equals. So we've got times it by 6 and then we're taking away 10. We're going to undo the take away 10. We'll add 10 to both sides. 6x equals 18. 6x means 6 times x, the opposite of times by 6 is dividing by 6, and that's going to lead to x equals 3. That works because if we put 3 in here, 6 times 3 is 18, take away 10, which is 8. Last one in this video, 2x plus 3 equals 3, sorry, 2x plus 13 equals 3. So we've got a timesing by 2, and then we've got an adding 13. Okay, we want to get rid of this adding 13. So we subtract 13. That's going to lead to 2x equals negative 10. We can get negative numbers here. 3 take away 13, start at 3, go down 13 is negative 10. And then we'll divide by 2. And that's going to lead to x equals negative 5. Negative 10 divided by 2, which is negative 5. Okay, we'll stop there with this first video. Those are the fundamentals. The next two are a wee bit more extended. Okay, so watch into the next video to see how we do those examples. Thank you.